Hi everyone, I'm Robert Ellen. I'm a senior consultant at Alembic, and tonight for GraphQL Sydney, I will be talking about GraphQL APIs for Postgres with pggraphql. So pggraphql is a Postgres extension that provides GraphQL APIs over Postgres databases, supports Postgres 14 and beyond. And the reason I have an interest in it is that I've been sort of reviewing low code, no code, and backend as a service options to support Jamstack style front ends. And yeah, pggraphql is a very new kid on the block in terms of being able to talk to databases in interesting ways and support the Jamstack kind of philosophy. So tonight I will go through pggraphql itself, and then how it can be leverage with other tools to provide the GraphQL APIs over HTTP, which is really what we need to support the web apps, Jamstack apps, etc. And there'll be a small demo and explanation of how that part works right at the end too. So, as I said, pggraphql, it's for GraphQL APIs over Postgres. It's a Postgres extension written in C and SQL, using some libraries out there that can parse GraphQL queries. And what it does is reflects over tables and columns within tables to build up a GraphQL schema, and then it can also resolve GraphQL queries and turn them into the underlying SQL statements. And with the addition of another tool called Postgres, we can serve GraphQL over HTTP, and we'll talk about that right at the end. And pggraphql, it's quite new. I think it's only in sort of 0.3 version territory. It's open source and it's developed by and for Superbase. So I should introduce Superbase in case that's not familiar. Superbase is an open source backend as a service built around Postgres with a large ecosystem of tools around that for authentications, functions as a service, logging, etc. Using, and their philosophy is to use sort of best of breed libraries. So there's a bunch of different languages involved in the different libraries there, including Haskell and Elixir for different parts. Superbase, as the name might suggest, is frequently compared to Firebase or as an alternative to Firebase, but it also competes with more generic hosted Postgres offerings like RDS, or those in Azure or Google. Superbase can be self-hosted because it's open source, or they do have a managed cloud offering, and they're really targeting the Jamstack.
I found something else. Do you want to know, is Superbase open source?
Apologies for that.
I'm sorry.
Yeah, Superbase is really targeting Jamstack developers who are not sort of experienced or experts in managing their own backend systems. And by providing an out-of-the-box backend, and everyone's sort of, many people are familiar with how Firebase works, similar kind of concept. yeah, people who are front-end savvy can build systems that need a back-end, need a database, need background processing, etc. So with Superbase explained, and going back to pggraphql itself, how do we use it? So let's imagine that we have a table in a Postgres database called count, and we select a user's ID and email address where, and we filter on the email address, so we get back the user ID and their email. So pggraphql allows us to express that same query as a GraphQL query. So it provides a function called resolve, and you can pass a GraphQL query in GraphQL syntax, with all the features in there, including arguments, etc. And here where we've got, you can see there's a filter on the email saying that it's got to be equal to cat@x.com. And if we run that down the bottom, we can see that we get back a payload in JSON that that looks like what you would get back from a GraphQL query. You can of course get a lot more fancy with that. So imagine we also, along with accounts, we have blogs that are associated to accounts, and we have blog posts that are associated to blogs. You can see that we can find all the blog posts on a particular blog that's owned by someone called aardvark@x.com. So we're filtering, we're getting their first their blog with an ID of 1, and we are drilling in, picking up all the fields we want, and then drilling into the blog posts, sorting them by created at time, and doing some pagination, and I'll get into what all these arguments mean and how that works. But yeah, you can go as fully featured and as deep as you want, because it's a complete implementation of GraphQL. So the way we get this GraphQL schema from the underlying Postgres schema is through reflection. So Postgres table rows get mapped into GraphQL types. Table columns and foreign keys get mapped into GraphQL fields, and then relations and groups of rows get mapped into something called connections. And a connection is a concept from the relay specification, and in which it is there's a part of the relay spec called connections, which is about best practices around pagination. But in PGSQL, the connections are also used for filtering and sorting of the result sets that come back. So it's worth going over the relay spec, or specifically the connection part of the relay spec, because that really explains the syntax that pggraphql provides. So yes, there's a relay, very popular framework for GraphQL, and yes, it has this particular feature called connections, which are best practices for pagination, and they specify arguments and particular objects in your graph that should exist to do to provide functionality such as slicing result sets, then pagination of the slices, cursors, and being able to indicate whether there are more results on either side of the current page that's been returned. So, as an example, if we have a schema that has users, and users have IDs and names, and then references to a bunch of friends who are users in their own right, we can see that in a query that follows the relay spec, there might be a node in the graph called friends. We can and then pass arguments to do the pagination. So this one is saying return a user and all their friends, but just the first 10 friends after some opaque cursor. And the opaque cursor, the opaque cursor is just some kind of opaque string that the client doesn't need to know about, only the server will understand. So further down in the same query, we can also specify the edges, which is sort of a connection from this concept of a collection of friends to the individual user records that are related to our sort of root user. We can get a cursor back, and then the node and that ID and name. The node is of the same type as user is at the top here. There's also another object that has next page and also has previous page fields. These are Boolean fields that can tell us whether there are more records before or after the current page that we're on. So yes, the four sort of features: slicing, we've got the first and last n, retrieving the first and last n results, fairly straightforward. Pagination, the before and after cursors, and that tells the server effectively an offset. So yeah, we can get the first 10 records after a particular point in the collection. And yes, as I mentioned, the cursor is an opaque string that can be of any format, so long as the server can map that to a particular record to know what the offset should be. The client can work out what cursor each individual record is, because there's a cursor field, and to work out if there are more results, there's the has next page, has previous page. So that's a kind of a whirlwind tour of the syntax or the structure of how tables can be mapped to GraphQL schema. And in the demo at the end, we will see a little bit more of that. It will be made a little bit clearer. So an important aspect of anything like this is what's the security story for something that's putting an API on top of a database. So yeah, pggraphql leverages Postgres security features, doesn't sort of really add anything in itself. So uses normal Postgres authentication. So you can imagine passing in a query from whatever application programming language you have that talks Postgres. That query will make a call to the resolve function, passing in some GraphQL. It's going to be authenticated just like any other database query coming from some application. The PG GraphQL and Superbase, the company behind it, they are very lean heavily into using privileges and row-level security features of Postgres to restrict access and the capabilities that users have. And they especially lean into row-level security, which is a slightly sort of, I guess, in certain circles underused feature of Postgres, especially when you've got applications in front of it that are in front of your database that are doing your user authentication. Often all the database queries come in on a single user, but the direction that PG GraphQL and Superbase as a whole is pushing is to push more security features into Postgres, and these features, including row-level security, are very powerful and expressive. So just to explain what row-level security is, you can create a policy on a table around some operation like insert, update, select, and put some restriction on there. So a basic one here is users can only update their own accounts. So this policy checks that the current user logged into this connection to Postgres is the same as the ID of the account that's trying to be updated. And if they're not, they won't be able to update. So this is how authorization relatively fine-grained, because the queries that you can put into these policies are quite flexible. You can join on other tables and make the logic there quite complex if you so desire. So that's PG GraphQL on its own. We'll see a little bit more of it in the demo, but so far we've been sending GraphQL over a Postgres query from wherever, either through a Postgres client or from some kind of application programming language, Ruby, Elixir, Java, what have you, Node.js. But that's fine. But we really would like to query over the internet. We really to fulfill that Jamstack requirement. We really want to be able to query our database over HTTP, and PG GraphQL on its own doesn't provide that, but it can be used in concert with another library called Postgres, which is a RESTful, provides a RESTful API over the top of Postgres databases. It's a very simple web server, and allows you to do all the HTTP verbs over tables. It also leverages Postgres security, as well as JSON web tokens for authorization. And I'll show the basis of what some kind of token would be required to do that. And PostgREST is also open source. So here's an example of using PostgREST through curl. It's a little bit hard to see, but here's the query. Basically the idea is that each table is a top level resource So account is a table in our database, so we can get that, and then we get a result set in JSON of that table. So we've got account IDs and emails, passwords, etc. So PostgREST itself is a very powerful tool, and Superbase do use that as well to provide a REST API over its hosted Postgres offerings. But how can we use that for what connecting to pggraphql? So Postgres provides an endpoint to call Postgres functions. It's prefixed with RPC, so RPC/function name. So yeah, whereas we would have previously had a table name in there, we've got RPC and the function name, and this is going to, if we post to that URL, it's going to call the function. So what we can do with pggraphql is post to the GraphQL resolve function, which is what we used to do GraphQL in native Postgres. And with that, it's sort of, those two combined, you sort of have something that's similar to solutions out there like Hasura, which also provides a GraphQL layer on top of Postgres databases. It's a lot more than that. The feature sets are kind of a bit of a mix and match, but it's getting there. So with that said, I wanted to quickly jump out of the presentation and have a look at pggraphql and Postgres together in an environment that should be relatively familiar to people working with GraphQL. So something that was just a little bit hard to put into the slides is there's a demo database schema that can be set up when you download the pggraphql library, and this is the SQL that it sets up. So we've got accounts, blogs and blog posts, and one feature of pggraphql that I didn't mention in my presentation is that you can pass directives to pggraphql by putting comments on schemas and tables. So there's various directives. I won't necessarily go into what they all mean, but that's a way of configuring the behavior of pggraphql. So we've got these tables, and the schema in sort of GraphQL, in GraphQL syntax that comes out is from that via reflection is fairly extensive. So there's multiple types. You can see there's an account type which maps to the account table, and different fields. We've got the connections, which comes from the relay spec for connections, where we can do the pagination, filtering, sorting, etc. And like any code generator, it's going to enumerate a whole bunch of types based on that reflection. But just wanted to show that it's quite comprehensive, and the documentation, while it's quite new, is pretty good for understanding how it all works. But yes, and so we can see how filters are implemented for the so there's inputs there for doing the arguments for filtering, etc. So just wanted to show that quickly. All right, so when we have PostgREST and pggraphql combined, we can jump over to GraphQL, which should be a fairly familiar tool to people. So this is their demo application up and running. in the background, and I've got a query here that that drills down into into accounts, blogs and blog posts, querying everything out, and I have already run it. So we can see this what this query is saying is get the account for Aardvark, get their blog with an ID of 1, get the first three blog posts in that blog after some cursor, and this is what the opaque cursor really looks like, encoded. So who knows what that actually represents underneath, but yes, so long as we know what it is, we can work with it. Yes, and the results back here, you can see that each node, which is the actual entity, in this case the blog posts there, each of them has a cursor. So that's how we can the client would be able to pluck one of those out if it wants to get records before or after a particular cursor. And so at the moment, this is sort of not using any authentication, but one thing that I can do, I'm just going to move that around a bit, is we can use JWT signed tokens for authentication. And so the core claim that PostgREST requires is a role. So in our JWT token, we have a payload that includes a role, and it's just a non. And we've set up PostgREST with a very, very super secure secret. And then we have an encoded token here. So if I was to copy this and go back to GraphQL and quickly add this in, hopefully this should still work if I but if I was to go back to JWT and say, actually, my role is something else, and take this one, yes, there is no role, and this is Postgres level authentication. There's no role called hacker in the database. If we were to add that user, add that role in, then that would have worked. So if the idea being that potentially users of some application, where some Jamstack application, will get roles added into the Postgres database underlying this, and then they'll get an access token for their particular role, and they will be able to successfully connect. And yeah, that's just the bare minimum. The other claims and other security within the JWT ecosystem can be added on to that. And one thing that, based on the demo gods, I won't try at this stage is mutations, but it goes without saying that mutations do work the same way. I've only been showing queries so far, but yeah, mutations are perfectly fine as well. So that is all I had. Happy to take any questions. Thank you very much for your attention.